We're at a huge house in Aylesbury which has 8 different solar systems, 3 different battery systems, 3 heat pumps, a load of electric vehicle charge points and a wind turbine. We've already installed 7 Tesla Powerwalls at this house. However, we're now back to add on a whopping 12 expansion packs, bringing the total battery capacity at this site up to 305 kilowatt hours, which is insane. I wonder if that makes it the biggest residential battery storage system ever installed. It's certainly up there. In this video, I'm going to take you around the property to talk through the various technologies and how they all tie in together. We're going to look at some of the solar systems as well as 3 different battery systems. They're not all Tesla batteries. There's also a battery system from another manufacturer in one of the barns at the back of the property. Later on, some members of the Tesla UK team are also going to be coming to the house to film their own case study of the install and do some interviews with our team and potentially the homeowner, Nigel. To start with, let me show you where we're installing the 12 Tesla expansion packs. This is the basement of the main manor house where we've already installed 4 Tesla Powerwall 3s, and this is where the expansion packs are going. They're going to be 3 expansion packs for each Powerwall 3, all neatly stacked in a row. Now we're actually going to be doing the expansion pack installations in 2 phases. We're starting with 3 expansion packs behind 1 Powerwall 3 for the first phase. We're then going to come back and do the remaining 9 expansion packs behind the other 3 Powerwalls for phase 2. Nigel has actually placed the order for all 12 expansion packs. The reason for breaking the installation down into 2 parts is actually to do with a current software limitation on installing the batteries. Essentially, the software to allow expansion packs to be installed on multiple Powerwall 3s on the same supply is not currently released yet. So if you do have multiple Powerwalls on the same supply, as is the case at this house, expansion packs can only be fitted to the main leader Powerwall for now until the engineers at Tesla release an update enabling all the Powerwalls to be fitted with expansion packs. At which point we'll be back to fit the remaining 9 batteries and we'll be back to make a part 2 to this video. So stay tuned for that. Let's go for a walk around the property and take a look at all the green technologies that Nigel has installed. To start with, let me show you the hay barn. This is where we installed 30 JA 440 watt bifacial solar panels earlier on in the year. This roof faces about 45 degrees off south and it has a slope of 10 degrees. The panels are estimated to generate 11,550 kilowatt hours every year. The hay barn also has 3 Tesla Powerwall 3 units that we also fitted earlier this year. The 30 solar panels have been split across the 3 Powerwalls with 10 panels feeding into 1 MPPT in each Powerwall. We're not going to be installing any expansion packs to this system yet, as the 40.5 kilowatt hours of storage capacity is more than enough to handle the electricity demand of this building for now. As you know, Powerwall is not currently capable of 3-phase power cut protection. So if you do have a 3-phase supply, you'll need to get a dedicated single-phase board separated out with only single-phase loads, and the gateway will provide power to that single-phase board in the event of a power cut. Tesla is looking at a 3-phase solution with 3-phase backup, and that's something that will really come in handy for those customers like Nigel with 3-phase supplies that are looking at battery storage. Now there's also a Tesla wall connector mounted to the outside of this building, which we also installed earlier on in the year. This wall connector is connected to all 3 phases and will output 22 kilowatts to the car. Now in the Tesla app, you can set whether you want the Powerwall 3 to power the car or not. In most cases, you're not going to use your home battery system to charge your electric vehicle, as it doesn't make economic sense while there are EV tariffs available with very cheap overnight rates. However, if you do want to use your stored solar to charge the car and drive on sunshine, as it were, then you can set that up in the Tesla app very easily. Let's go and take a look at another much bigger barn on the other side of the property, which has a huge solar system mounted to the roof, as well as another battery system from a different battery brand called Alpha ESS. On the way, I'm going to tell you about how much you can save on a three-phase supply with only a single-phase battery system. So something that comes up quite a lot is, how does the Tesla Powerwall system work on a three-phase supply? At the moment, the Powerwall is only designed to operate on one phase. A single unit can't supply power to multiple phases at once. So if you want power supplied to all three phases, you need to get a Powerwall for each phase. However, even if you only have a Powerwall installed on one phase, you can still achieve a cost saving on electricity used on other phases through something called net metering. So let's say you have a Powerwall on phase 1, and phase 1 is drawing 2 kilowatts. Powerwall will output 2 kilowatts to supply the load. If phases 2 and 3 then kick in, drawing 5 kilowatts for example, then Powerwall that is on phase 1 will output 7 kilowatts. 2 kilowatts will go to the load on phase 1, and 5 kilowatts will actually be sent back to the grid to be exported. If you have a modern three-phase smart meter that is capable of something called vector sum metering, then that works by looking at the net reading across all three phases. So if all three phases are drawing 7 kilowatts, but one of the phases has a Powerwall that is outputting 2 kilowatts to its own phase and 5 kilowatts that's being exported to balance the other phases, then the smart meter will have a net 0 meter reading, and the meter will not tick up. This means that you can save on bills for the whole three-phase supply without needing to have a battery wired to each phase. So Powerwall 3 monitors all three phases and then discharges accordingly with the aim of making your electricity meter read 0. So what is going on at this site, and why is there such a demand for electricity? Well, the property is sort of split into three sections. You've got the large manor house, then you've got the stud farm with the stables, the horse walker, as well as a vet, and finally there's a cottage on the outskirts. I don't know how much electricity the whole site is drawing because there are a number of three-phase electricity supplies dotted around, all feeding each of the buildings. But I can tell you that the manor house by itself is drawing between 90 and 100,000 kilowatt hours of electricity every year, hence the need for 216 kilowatt hours of storage. There are a few major electrical loads on the house, including 3 heat pumps feeding directly from the main consumer unit, as well as a swimming pool. Overall, there are 8 different solar systems at the property, a combination of ground-mounted and roof-mounted arrays, all helping to meet the site's massive energy demand. Welcome to the biggest building on this site, which we're calling the Horsewalker Barn because it has a horsewalker in it and we're creative. Now this building has a very big solar system on it. In fact, it's the largest system installed at this property. I don't know how old it is, we didn't install it, but I've taken a look at the panels and they look as though they're at least 12 to 15 years old. The panels are feeding into these two 20 kilowatt SMA inverters that are connected up to a three-phase supply. This barn does draw quite a lot of power. There's a horse walker, a big duo lift and a septic tank all feeding from that distribution board. Behind me, we've also got this battery system, which is a 49.2 kilowatt hour Alpha Smile T10. Now this was actually originally installed by another firm and was fitted in the basement of the main manor house, where we've now installed 4 Powerwall 3s and are in the process of adding 12 expansion packs. When Nigel came to us looking to upgrade to a Powerwall system for the main house, part of the project included moving this Alpha battery system from the basement of the main house into the barn. Now, one of the main reasons for upgrading the house's battery setup from Alpha to Powerwall is that the Powerwall system can be scaled much more easily. With this Alpha system, the largest capacity that could be fitted on one supply is 49.2 kilowatt hours with 10 kilowatts of inverter throughput. However, with 4 Powerwall 3s in the main house and 12 expansion packs, the battery system in that basement now totals 216 kilowatt hours with 38.08 kilowatts of inverter throughput, which is a vast improvement and makes a much bigger dent in the house's humongous electricity demand. Let's go take a look at the final piece of the puzzle, the wind turbine. Now you might be able to see behind these trees a great big 15 kilowatt wind turbine. Now that was installed in 2008 and it's connected up to 3 7 kilowatt SMA Windy Boy inverters. The turbine and solar systems complement each other quite effectively as they sort of offset each other's limitations. Solar panels generate the most electricity during daylight hours and are particularly effective in the summer months when days are longer and sunnier. In contrast, wind turbines often produce more energy during the autumn and winter when wind speeds are typically higher and solar output is lower. This seasonal and diurnal balance helps to smooth out the variability of each system on its own, increasing the overall reliability and self-sufficiency of the household's energy supply. Unfortunately, domestic wind turbines are generally unviable in the UK for a few reasons. The biggest reason is that you really need to have quite a tall turbine with access to unobstructed airflow. So ideally, the turbine needs to be 5 to 10 meters above the nearest buildings and the nearest trees, which very often means you'll need a freestanding mast reaching a height of 15 to 20 meters. You'll also need quite a large turbine with a radius of at least 1.5 meters to get any sort of reasonable payback period. These factors, combined with the noise, maintenance and planning requirements, generally mean that domestic wind turbines are not feasible, unless, like Nigel, you have quite a large open area and the means to get one fitted. If you would like to learn more about domestic wind turbines, I'd recommend watching Gary Does Solar's video on the topic. Gary goes into great detail and breaks down the cost benefit and the nuances of getting a proper wind turbine installed at a residential property. He also compares wind with solar as an investment. Right, let's circle back to the main manor house to see how the expansion pack install is coming along, and the Tesla team should be turning up soon to film their video and do some interviews. Tesla expansion packs can be installed in two ways. They can either be mounted adjacent to the main Powerwall 3, or they can be stacked behind it. In this case, we've chosen to stack the batteries as we're short on space, but it would look pretty epic to have 16 Powerwalls all in a line on a wall. I look forward to seeing someone do that one day. So as you can see, because we're stacking them, we've had to take the main Powerwall off the wall, disconnect it, and then fit the expansion packs behind. If you are looking to get expansion packs retrofitted to your existing Powerwall 3, then I would advise mounting them adjacent instead of stacking if that's an option, as it will be a quicker and therefore cheaper install. It's pretty easy to fit expansion packs. The back one mounts to the same wall bracket that the main Powerwall was attached to, and then the other expansion packs are all mounted together on the same bracket. They're linked together using a single cable called the expansion harness. All the electrical connections are built into that one cable, and the cable is available in 3 lengths: 0.5 meter, 2 meters and 4 meters. In this case, we're obviously using the 0.5 meter cable. Remember that if you are stacking Tesla batteries, then they all need to be floor supported. You can't have the main Powerwall mounted above ground and then install an expansion pack behind, as the wall bracket is not strong enough to hold 250 kilos of Tesla battery. So that is something to think about if you're getting one of these fitted and considering expanding it in the future. Now, those of you that have seen our many videos on Powerwall 3 may be thinking, well, how have they put 4 Tesla Powerwall 3s on a 3-phase supply? I thought you could only have 3 on a 3-phase supply. And you'd be right. In most cases, if you're installing single-phase Powerwalls on a 3-phase supply, then you are limited to 1 per phase. The reason for this is that the DNOs generally want the phases to be balanced, so they only allow you to install 1 Powerwall per phase. They don't want to see 20 kilowatts on phase 1 with only 10 kilowatts on phases 2 and 3, for example, as this causes voltage instability and degrades the power quality for other electrical appliances on the local network. So in general, the DNO requires an even split across the phases so that the grid remains stable. However, in this case, we really wanted to put 4 Powerwalls on this 3-phase supply. So we asked the DNO if we could put 2 Powerwalls on phase 1. And they said yes, which is excellent. Unfortunately, you can't have any more than 4 Powerwalls on one supply due to a technical limitation in the Powerwall system itself. Maybe that will change with the 3-phase Powerwall product. It's the last week of April at the moment, and yesterday the house used 175.5 kilowatt hours of electricity. It was a pretty sunny day with some light wind, yet the solar and wind turbine only managed to supply 28% of that 175 kilowatt hours. The Powerwalls off-peak charge fully every night, and they also charge off excess solar and wind. Overall, the solar, wind and off-peak charging managed to account for 71% of that 175.5 kilowatt hours, which is pretty good. And we find that most households can achieve a 70 to 80% level of annual grid independence with an economical, sensibly sized solar and battery system. However, yesterday was a pretty decent day for the solar and wind generation. So far, in the first 4 months of this year, 60% of the 26,000 kilowatt hours consumed by the house has come from the grid. Only 18% has come from the solar and wind turbine. And that's the reason for all these expansion packs. When the solar and wind is not contributing much, the batteries really need to off-peak charge to actually make a dent in the electricity bill over the course of the year. Those of you who have seen our other videos on Powerwall may be thinking, well, a Tesla Powerwall 3 with 3 expansion packs takes 6 hours and 45 minutes to fully charge up from 0%. So that's not quite long enough for the batteries to fully off-peak charge in the overnight window of most time of use tariffs. However, there is a tariff with a 7-hour overnight window, E.ON Next Drive. And that's exactly how this has been set up. With E.ON Next Drive, the Powerwalls were just about fully charged from 0% during the 7-hour off-peak window of the tariff. So that's a wrap. We've done all our interviews with Tesla now. The expansion packs are fitted and commissioned and working well. If you're still watching, I hope you found this video interesting and maybe learned something. We'll be back to install 9 more when Tesla update the software. See you then.